a more general philosophy paper, Variation du style mathématique. One of the things when we are having a conference on mathematical cultures is, of course, what is the difference between culture and style? Maybe there is none. Maybe these are interchangeable if you really want to go into the notion of style. So Chevalier talks about styles, and he says styles in mathematics change over time, and he calls a change from one to the other. He calls it a revolution, but this must not be taken too literally. And then he essentially discusses in this article, I wrote it quickly, only two styles, and he sets them against each other. It's Weierstrass's style of the epsilons. His point about that, you know what this means. I mean, doing precise analysis with defining the continuity in terms of epsilon, the convergence, and so on. And also, this is important because it's not brought out by epsilon alone, the fact that you construct your real numbers. You construct everything, all the objects, in an arithmetical way, from whole numbers, rational numbers, sequences, and so on, data cuts, whatever. So this is that type of arithmetized constructing analysis and mathematics, which at the time, as he explains, was an answer to these counterexamples, these weird functions that nobody had seen coming before, and so on. And he contrasts this Weierstrass style to the current style that he is now presenting and advocating, practicing, of the 1920s and 30s. And the transition between the two is exactly what was mentioned in the talk this morning. I mean, the fact that, for example, Chevalier, I mean, in this tensor definition, he wants to do it without coordinates. Choosing coordinates spoils natural invariance of the notions, whereas you are now looking in this structure-oriented mathematics, you are looking exactly for the true aspect of your object that you are studying, which is invariant under such and such, and try to place every theorem in the context of a proof, which, at one point he says it in the paper, has the same group of transformations as the theorem. The proof should have the same group of transformations. You should find that. So it's a picture of complete paradise and harmony. It's like once you apply this conceptual analysis, this axiomatizing analysis of your mathematical results, everything falls naturally into place. And this paper can, of course, be read as the first manifesto before the name of Bourbaki. It is the first manifesto of Bourbaki. If you read it, that's exactly what it is. But that's not all that Chevalier thinks when he writes this, even though it is not in this paper. So if you surround this paper by his other writings, you find other things. For example, there's another publication on Vigueur in Méthode axiomatique, which does still not disclose the real thing, but you find what he is after and why he praises this new mathematical method, this Bourbaki approach, in such an intense way, when you look at things that he co-authors with Armand Dondieu, one of the founders and principal driving minds until his death in early 1934, I think, of the Groupe Ordre Nouveau. So here again, they do not only publish in their own journal, Ordre Nouveau, political journal, but also again in the philosophical. And there is this Hilbertian logic and psychology. And so to get to the point of this paper, and which leads us beyond what we have seen before, we are thus led, write Chevalier and Dondieu, to describe mathematics as a purely formal science, in which every intuitive act is confined by an irreducible datum, the axiom that we have given you, and which proceeds by operations of the mind that are analogous to meta-mathematical reasoning, but out of necessity contain concrete psychological elements. And then, a little later here, comes this thing which repeats precisely the political statements that Ordre Nouveau always makes. We are neither Marxist nor capitalist, neither this nor that, neither ni gauche ni droite, and so on. We are not all of that. And so we are neither in favor of Dedekind's deductivism, neither in favor of mathematical intuitionism, be it Borel or Studi, he doesn't mention Brouwer here, and so on. Rather, the point is, what is given to the Hilbertian mathematician, the axioms that he starts from to develop a field, what he works and acts on in the course of his ongoing progress towards generality will be itself, well, it will be abstract from a logical point of view, but from the psychological point of view, because this is the concrete thing that he is working on and trying to develop and show what comes out of it. From the psychological point of view, it plays the role which in other forms of human activity develops upon concrete. That's the point. So, Chevalier, in his thinking, partly helped by Dondieu, but anyway, I mean, they were in contact twice every week, as long as he was alive, and then Chevalier carried on this thing for another 8 years in publications. Chevalier found a way of integrating this human factor, which almost strikes us as holistic, which may remind us of the voluntaristic aspect of Ginger when it comes to axioms, carry this over into his Bobakistan mathematics, which is quite amazing. So, just to give you the background, I mean, these are 3 books authored by Robert, not Raymond, Robert Aron and Armand Dondieu, around the time where the crisis hit France. Le cancer américain, la révolution nécessaire, décadence de la nation française, you get the idea. So, and what, of course, I mean, these are total books, every single one of them. I mean, the whole word is constructed and so on. And this is the L'Ordre Nouveau, the journal that they have. What is expounded in these books, and what apparently, according to what they tell us, was the invention of Dondieu, is the méthode dichotomique. So what is the dichotomic method? The dichotomic method, which is at the heart of what Chevalier thinks about mathematics and how one should and really ought to do mathematics, is a method by which you separate in every single subject you are addressing the truly human from whatever is non-human. For example, typical example that Dondieu always gives of his dichotomic method, you look at a worker in the factory, a very important subject for their reflections. They actually, in 1935, they go there, no, 34, 35, in the summer, they actually go into the factories in order to give a few workers that they substitute for 2 weeks of paid holiday. They work for free in factories. They only do this once, though. But anyway, but you see, I mean, they're really, so the dichotomic method applied to the worker in the factory is, look at what the worker does. He is there in front of his machine. So there are things that he does mechanically which a machine could do for him. This is no good. This you separate. Whatever remains is the kind of work which is something that a human being should be doing. So this is dichotomic method. Separate between the two and then try to change the world so that human beings are only doing creative work. And what I was just showing you is the application of the dichotomic method to mathematics. There are other articles where he applies the dichotomic method to physics. Of course, Vienna Circle is out, so they are anti-positivistic, and at the same time they are scientists in a way. So it's this incredible way of being between the dividing lines that everybody seems to take for granted. So okay, necessary evolution, reflection centered on truly human element. I already said this. Méthode dichotomique. This is funny. This is at the very beginning of this whole reaction, intellectual French reaction to the economic crisis at the end of 31. There is a special issue of Nouvelle Revue Française, Cahier des Revendications. So it's a list of what everybody is is asking for these groups, and there it's Chevalier and Dondieu who present the ideas of Ordre Nouveau, and the title is L'intelligence épée, intelligence as a sword. Intelligence is not a mirror nor a tool, as other philosophers would say, it's a sword. This concept refutes capitalism, Marxism, pragmatism, and behaviorism, and so on. They're always in the middle. The greatest conquest of human intelligence is the creation of an abstract language and world. Science is, in the first place, an intellectual creation which is the fruit of aggressiveness and risk. It could not continue to evolve further if it were not for the parallel development of risk and aggressiveness. And here are some of the titles of his articles. By no means all of them. There are about 30 articles of this sort, applying the Diatomic Method, for example, to the question of frontiers, borders in Europe, coming up with the idea of Europe of regions. This is also presented as an application of the Diatomic Method, very systematic. This is unfortunately because I didn't, in that library, they didn't have a color copy. This arrow is red, gleaming red. Nous voulons l'ordre nouveau. Okay, so this was my presentation of Chevalier and his human factor, and I contend that it is in this way that one has to read this Bourbaki Manifesto before the name in 1925, this Variation du style mathématique of Chevalier. I come to my last person, Teichmüller, known as the ultra-Nazi among the mathematicians, and certainly at the same time an extremely original mathematician. Very petit bourgeois background. Apparently the family suffered quite badly from the economic crisis which hit Germany, of course, at that time before France. He comes to the university in 1930 in Göttingen, sits in on various courses, and then he joins the SA, not SS, not, I mean, of course, NSDAP, the party, but I mean, most of all, he joins the SA, the stormtroopers, very early on. The idea being, and this was a role played by the SA until 1934 for a great many followers of the Nazi movement, the SA sort of tried to incorporate some sort of revolutionary idea, creating a new man. And in November 1933 in Göttingen, he leads the boycott of Edmund Landau, and he justifies this with a letter, a written letter, which here is a little excerpt. I'll show it to you in English in a second. Before going to this, something which is also quite typical of the time, and I could develop this further, but I don't have the time to do it here, is that he then, after that, when Hasse has come to Göttingen and is there, even though the Nazis like Teichmüller did not like Hasse either, he was too conservative in a non-Nazi sense, too not sufficiently revolutionary for them, he agrees to participate in this famous seminar in Göttingen on structure of local fields, whatever, because it is not run by Hasse. This is typical. So it is officially run by Witt and Teichmüller and so on, the young students. It's a spontaneous activity of the young people. The young generation is taking over. And formally, Hasse is in the background, even though Hasse gives the subject, publishes the papers in Press Journal afterwards and so on. So the thing here that he writes to Landau as a justification of the fact that he has led the student boycott of his lectures, which then led to Landau's dismissal. I also know that many university lecture courses, especially the lectures on calculus, have an educational value also. They not only lead the student into a new conceptual world, but also to a new spiritual adjustment. Says it like this. But since the spiritual adjustment of every individual depends on the mind that is to be adjusted, and since this mind depends, according to principles which are not only known today, but have been known for a long time, on the racial composition of the individual, It will, as a rule, not be recommended to have, for instance, 80 Aryan students taught by Jewish teachers. I can testify to this from my personal experience. He used to calculus lectures he took from Courant. Okay, so why am I'm mentioning Teichmüller because the question arises: what is this? This letter is part of this political fight that he does, and he does it. But so you can say lots of things in such a letter, and you talk about calculus or whatever. Is this rhetoric, or does this affect his doing mathematics, his mathematical practice? So there is no effect of this which is comparable to what we have seen with Bauer or with Hermann Weyl, in the way that they took a certain thing that they felt very strongly and changed, for example, the foundations of analysis or the way of conducting logical proofs in mathematics. There's nothing like that. It is an effect on a lower scale, and concretely the choice of subject that he works on. He leaves the number theory, the arithmetic algebra, structure of complete fields and so on that he had been working on in Göttingen. He physically leaves from Göttingen to Berlin, where he's close to Bieberbach, so he feels politically more at home. And he changes the subject to geometric function theory, and then goes on to his Teichmüller theory. And then occasionally in his papers written in the later period, not in the papers that passed through Hasse's hands and got published in Prelude's Journal, but in the later papers you have glimpses of things like that. For example, in this paper here from 44, it was written before, it was published in 44. He says, he discusses the moduli of elliptic curves, and he says, well, so you have this J function, and you want to know that this J function is a conformal function. Now, conformal, of course, ever since Riemann and Klein has been charged with a lot of meaning in terms of intuition. I mean, in German textbooks, conformal is defined by leaving angles invariant, which is a stupid definition, but to appeal to intuition. So he plays on that tradition, saying that something as geometric as the conformity of the J function I do not want to deduce from power series expansion. So I have now talked for 53 minutes. As I see, I think I would just stop here.